working principle of the AND gate is simple. The signal at the output terminal of the circuit is low, meaning at ground level, whenever at least one of the input signals is low, because the potential is pulled to ground by the forward biased diode, respectively by both diodes. The output is high, meaning at the potential of the positive supply voltage only if both inputs are high, because now both diodes are reverse biased and the potential at the output clamp is pulled to the positive supply voltage by the pull-up resistor. I am using LEDs instead of normal diodes at this demonstration circuit. The LED is lighted up whenever it is forward biased, which applies whenever the accordant input is at ground level. Only if both inputs are high, the LEDs are turned off and the output signal is also high, which correlates to a potential of approximately 12V. The low level at the output terminal differs clearly from ground level due to the voltage drop across forward biased diodes, which depends on the type of diode and is never zero. We can detect 2V by using LEDs.
Here you have the symbol that represents an AND gate. You can see it has two inputs and one output. The output depends on the status of the input. Here we have the truth table. It represents the status of both the inputs and the output. As you can see, the values are zeros and ones. This is due to the fact that logic gates use binary number system, which is based on 2, so there's only 2 numbers. The reason is very simple. Logic gates are basically made of switches, and there are only 2 states for a switch, on or off. The on state is normally represented by the numeral 1. The off state is represented by the numeral 0. Also, the on/off states can be represented as true and false. For this demonstration, I'll be showing the status of both the inputs and output as true and false. Here I used momentary push button switches to represent the inputs of the AND gate, and a light bulb to represent the status of the output. Whenever the light bulb is dark, as it is now, this represents a 0 or a status of false. Whenever the light bulb is lit, this represents a 1 or a status of true. Whenever the input is true, then the switch representing that input will be closed, and if the input is false, then the switch representing that input will be open. If you observe switch A, you will see it is currently open. In this state, the current will not flow through the switch. But now, if you observe switch A, it is now closed. In this state, current will flow through the switch. Here in the truth table, you can see that both inputs of A and B has a status of false, and the result of the output is also false or 0. But when the values of the switches is false and true, as you can see with input B is now true, the output is still false. Now the A input is true and the B input is false. The light bulb is still, or the output is still false. But when both A and B is true, then the output is true. This is the only time that the output is true with the AND gate.